So I think we can begin with Sandeep and Varaprasad.
Okay. Yeah. So we have two options. One is I wanted to show a little bit of theory in terms of the current things that are happening. The second thing is with respect to the one more notebook that we had to finish. So which one do you guys wish to start with? You can lower your hands. Everybody lower your hands and maybe uh, we'll start with theory or notebook, whichever you guys are okay.
We can start with the theory, sir.
Okay, fine. Good enough, right? Everybody, I think a little bit of change
Yes,
also
sir.
is useful. Yeah. So, you guys, how many of you guys are in DevOps roles? So, how many of you guys? Maybe out of 15 people or 8, 10 people in the class, can I assume 7 people are in DevOps?
Yes, sir.
Right. So, so can you somebody give maybe a 1 or 2 minutes of what you guys do in the DevOps? Like, what is this DevOps means? Not your role in the company, but DevOps, what does it actually signify?
Sir, it comprises of both dev and operation, basically managing the infrastructure and also managing or moving towards infrastructure as a code. So these are the basic things.
Correct, right?
That focuses.
So first thing is, yeah. So first thing is the managing of the code itself, and second thing is the operations also, right?
Yes, sir.
Yeah. So similarly, now currently, let's say for a task, we are telling that we are building a model, right? ML model. Now the natural question is we need to maintain the model. We need to know when to retrain. We also need to know how the data will come to the model for model to do the inference, right? Because in reality, it's not that somebody will put it in an Excel sheet and ask you, okay, do the pandas, load the data and all that, correct? So it's a flow that is coming, correct? The data that is flowing into the system, and we need to know where exactly we need to store the data, where exactly we need to trigger the model to do the inference. And after the inference is done, we need to take the call whether the inference is good, bad. Do we need to take the feedback whether that particular thing is happening properly or not? And let's say I have 10 different versions of model. How do you take care of the version control? Which data to use for which model, right? So all that particular thing now currently a new area is emerging and it's called the ML ops. Okay, so you can call it operations, you can call it whatever you want, but it's called ML ops. And basically nowadays, like for example, people are using GCP or Azure or AWS. A lot of these things are inbuilt. Like for example, the CI/CD, the continuous integration and continuous delivery, they are inbuilt. But we want to really understand what's exactly happening, right? That's where I pulled out one Google Cloud paper which came in May 2021 and pretty recent, like not many changes happened after that in terms of this particular field. But I wanted you guys to give, I want to give a flavor to you guys, like how exactly it looks like in terms of the thing. Okay. So previously while doing ML, we had three parts, right? Representation, evaluation, and optimization. Similarly, in the ML particular ML ops, it can be divided into three things. One is the data engineering, the other is the ML engineering, and the third one is the app engineering. Okay. Data engineering with respect to how the data is flowing into the system, and also how are you maintaining the data, how are you validating the data, and all the aspects related to how the data is entering the system and also the kind of organization of the data and all that. And the second thing is with respect to validation of data. All that happens in data engineering. Please ask questions, guys. This is very new in the sense that this was there, but the terminology could be new. Okay. And the second thing is called the ML engineering. ML engineering is with respect to you will impose the conditions of how the data should look like, then you curate and do your pre-processing of data, then you infer the model and all that. Now, after the model is inferred, now you need to know where to give the data or where to give the results or where to show the results, right? That's where your app engineering will come. App engineering is more of you have an app or you might have a like a app on a desktop, or it could be just an app on your mobile, right? And you need to display how the results will look like. And let's say for example for that app you are looking at some KPIs, that is your key performance indicators, and we want to see whether that particular model met that indicators or not. And in case the performance is below, then you need to give the feedback to ML engineering whether to improve your model or do whatever possible, right? So this is like a interplay between data, ML and app. The engineering pieces are interplay. Now let's actually dig a one step deeper into what each of these are. Okay. Before that, we are now looking at the entire life cycle itself. So the three parts are now data, ML engineering, app engineering, right? But if you want to look at the entire life cycle, like previously we used to have the life cycle of a software product, right? You might have people might be looking at waterfall model. First you will put the requirements, then you will create the design document, then you will code, then you will maintain, then you will do testing and those kind of things, right? So similar to that, you also have the thing with respect to for data and model management, you have a life cycle. And what is that life cycle? It's an iterative kind of thing. It's not like after this the other will start, not like that. It's an iterative thing in process. So in the beginning what happens is, in the beginning you basically have the data that is actually coming into your system, right? So in that, if I want to look at the model itself, I need to develop the model. So that is your development, and when to develop, when to retrain, all that kind of a thing, right? Continuous monitoring. Continuous monitoring means basically you're trying to look for, is there anything like the model is trained on some data, and the current data that is coming, is it in the same distribution or something different is coming? And the second thing is also with respect to, I need to take the call when to retrain. Those kind of things will come into continuous training. Training operationalization will come into what hyperparameters to use, which data to use for training, how do I set the parameters, which version to use, all that will come into your training of, once you deploy a model, you do your hyperparameters and all that kind of stuff, right? Then you do the training. After you do the training, you now do the deployment of the model. After you deploy the model, you do the serving. Serving means inference of the model. And once you serve the model, you will get the predictions, you will get the results. Now I need to monitor to see whether everything is fine or not. This monitoring is with respect to the data also, like for example, some data is missing and all that, and also the performance of the model itself. So if you look at the both the data and model management, that is in the center, because that will form crux for all these things. So for example, the versions of the model, the versions of the data, the organization is now connected to all the pieces that are there, correct? So any doubts here? Anybody, any doubts?
Sir, will this prediction part will also be part of this life cycle?
Prediction is your prediction serving. It's part of the life cycle.
What is serving here as such?
Serving means basically, so for example, for us, everything is a service, right? So now prediction is a service for us now, right? And the second thing is, you might have multiple different clients that are there, and you might have multiple different versions of the model. Which model to be used for which version? of the particular client and all that. So there is a lot of logic inside also, right? Service also is there and also the prediction is there. So both together, because the intelligent component, you're trying to put it as prediction serving. Like for example, I might have a model to do image classification, but one guy opened it in desktop, that particular thing, the other guy opened in the mobile, just for example. And this is mostly demand based kind of a thing. Now, when that mobile thing interface requests that I need to know what the answer is, I might look into only the maybe a smaller model, maybe a mobile net or a small version of the model could be served for inference and you might get the result. While if it is a desktop version and if you have resources and all that, you might use a different version of the model itself. And in case, let's say that particular infrastructure has a GPU and all that, you might use a different thing also. That's why it is called prediction serving. You're not just simply doing a simple inference. You're also looking at the logic of what to serve, which model to serve, which version of the model to serve, and for which client, all the policies, all that actually put together, everything will form into the serving component. Does it answer your question?
Thank you, sir. Yes.
Okay.
But I have a follow-up question, sir.
Yeah.
How will the client capabilities be known to the server which offers the service?
So metadata, right? You can, when you're triggering the request. So for example, there are two phases. Okay. What you are now seeing is your, the already the interaction has happened and now you're trying to work on it. In the beginning, there is something called client onboarding phase, where a new client gets onboarded onto the server, right? So, for example, you can share some metadata with respect to that, and also the capabilities in terms of bandwidth, then the protocols that needs to be followed, then the time or the frequency with which the model and client needs to interact, and in case some security pieces are there, in case some privacy pieces are there, and also authentication logs, right? And also where do you store your what is that, the prediction logs, where do you store your monitoring logs, all that is basically one config file that needs to be sent from client to server, so that server will understand. Based on that, server knows what to do, correct, right?
Okay,
So
okay,
that
okay.
particular thing is called client onboarding, right?
Hmm,
Like
hmm,
for
hmm,
example, I basically downloaded an app.
hmm.
After I download the app, do you think in the first time only you will be using the app? You need to register, you need to do a lot of these onboarding processes, right? Like giving
Correct,
permissions
correct.
to what, permissions to this and all that. But in background, the client might, so because the user need not know about the these things what we talked about, right? So those things can be sent like a config file so that it will understand, correct? So
Yeah, yeah, yeah.
it's much little
Understood.
deeper than what we see in this particular thing.
Yeah, yeah.
Did I answer your
So,
question?
and that config file itself, yeah, if I understand correctly, that config file itself will be different for different deployments,
It's
like
dynamic.
app.
It's dynamic config based on the. So for example, you would have seen, right, the maybe the DevOps guys, when they're installing the thing, some of these the run files that are there, it will tell that if the OS is Ubuntu, do this
Correct, correct,
steps. If the thing
correct,
is
correct. Yeah,
Windows, so it's like a switching kind of tags and all that will be there, right? So
yeah, yeah.
similarly, for this version of let's say the GPU, you need to use this code, this TensorFlow version. All the dependencies what you're talking about, they come dynamic in nature based on the um, constraints also, and the second thing is the environment on which you are loading this also.
Okay, okay. Thank you, sir. I understood. Thank you.
Yeah. Any other questions before I go to the next one? So now this is becoming popular. So you go and tell that I am a data scientist, people will just look up to down, because data scientists will only know this ML development, will only know maybe training operationalization, but and also maybe prediction serving in inference part only, or he could deploy the model as a service. But how about continuous training? How about continuous monitoring? How about the data and model management? All these three pieces actually come into your ML engineer I was talking about, right? There is a role called ML engineer, which is actually make sure this pipeline that is there, it will be continuous, seamless, and also what is the output that needs to be given to the next one kind of stuff. So now the capabilities are okay. I'm a data scientist. I know ML, I know DL, I know which model to use, which scenario. That's fine, boss. How the data is coming to your system? How are you managing your model? How are you doing your improving the training continuously? Like last session, somebody was asking, I might have trained on something else, but now data is different. How are we making sure uh, the model is up to date, right? So those all things will come into picture. And how are we monitoring? Not that you just deploy a model and for lifetime that same model will exist. No, right? So how are we going to do that? So all that actually forms this called ML ops. So it's the combination of ML engineer portfolio plus the data scientist portfolio as well, plus little bit of data understanding, data lake, that whatever you want to call it. So all big data engineer or whatever they want to call, right? Like they will write these NiFi scripts to pull the data and all that, everything put together. Now people are calling it, you need to understand the data engineering, ML engineering, and also the app engineering. On top of that, like let's say the app engineering, there should be a way for you guys to understand, okay, I'm writing some JavaScript code or maybe some code on top of the app for it to interact and all that. But the integration with respect to the ML engineering and data engineering is a crucial piece. The integration with respect to the ML engineering and app engineering is a crucial piece. So that's where uh, the roles are now opening up. Okay, so I'll share this PDF with you guys. That's a different thing. But if you just look at that thing that we talked about, right? The same thing you're talking about. So you have the data and model management that is important, that is in center. So now let's say I developed some code and I developed some config file. Based on that config file and hyperparameters, now I'm trying to create a training pipeline. And that training pipeline is now fed and you actually do the training. And once the training is done, you are now giving the model to it, right? The whatever model that you developed, that is gets deployed, and it will be like a serving package. So you're deploying based on that config and what's the package, and you package it and send it. And after that you do the prediction serving, so that you will get for each of the inference the logs associated with that and the other kind of metadata. So that is your serving logs, and these serving logs are continuously monitored, and for each of the pieces the data and model is important. And when you created the new model, that is your model deployment, right? There is an arrow that goes into the model management, because the new registered model should get into the database. Similarly, after you trained it, you actually put the version of that into this, right? And the second thing is with respect to, let's say I did some deployment, maybe a little bit of pre-processing, whatever kind of things are needed, the modules that are needed, the data that is needed. So there will be a back to forth kind of a interaction here. And the last thing is, after monitoring, let's say I need to take decisions of whether I need to stick to the same model, I need to change the different model, or data is changing and all that. That's why you actually see a dotted line with respect to this. So at each stage, except for this one, this is not a what to say, a intelligent phase, but just config to pipeline creation, more of a code and all that. The all other pieces you see, it actually interacts back and forth with respect to data and model management. Okay, so this particular thing is called the ML ops process, and we'll go one by one deeper. Any questions, anybody?
So suppose we have an up and running process following this flow that you just showed, and we have after 2 or 3 months we have the new data coming in. So how do we compare the new data with the older data? Just
That you,
to
that you do the continuous monitoring, where you look at data shift, data drift and all that. So that's where you look into the new data that is coming versus the data on which the model is trained. You will find out the distribution difference, whether you're working on the same data or a different data. And the second thing is with respect to the model doesn't perform good. right? So that is also one way to tell that the data that is coming is a new data. So there are multiple mechanisms in which you will know that data that is coming is a currently a new data or something else, right? So did it answer your question?
Yes, sir.
Okay. So you might go in through this document, but what I wanted to say was, so on top of all these that are there, you also have set of pieces, like for example, on what infrastructure, on what security and privacy policies, and also there will be some repositories of with respect to continuous integration and continuous delivery. Like for example, let's say some config changes in something, the necessary changes that are needed for each of the other steps and all that will be formed in CI/CD. And you also have the artifact library, that is with respect to how the data distribution is there, or how ML some metadata with respect to that, all that you also have a repository. On top of that, this is what you generally guys you do, right? You do your you perform experiments to see what is the you do your experimentation to do the initial data kind of a validation in terms of understanding the data and all that. After you do, you will understand which pre-processing module you need to use. Then you will do the training, then you will do the evaluation, and then the serving. But after you do the serving, when the data is continuously coming, you do an online version of experimentation, whether the same model is okay, or I need to do incremental, I need to do other things and all that. Then this monitoring happens with respect to how the model is performing on the data, and the ML pipeline to make sure that there is no issues, or there is no like missing data and all that kind of a stuff. And you also have a registry with respect to model, so that you will have the versioning. And let's say the new model is not performing well, then I need to have a way back to go to the previous version of it. That's why you have a registry for model also. And also you have this for data and features, you also have the repository. So you have two things. One is your ML artifact repository with respect to hyperparameters and other kind of stuff, like configurations, weights, different layers and all that. And with respect to the data, you also have the repository, and it is continuous, like this all interacts with the all the different stages of it. So these are the different technical capabilities that we are looking at. But let's go one by one. Okay, let's not get thing, but want to go one by one. So you have three steps, right? In the beginning that we have. One is your ML develop. So 7 steps that are there, right? We will go one by one to see what happens. Okay. In the beginning, you have the data engineering aspect, which will make sure that the data comes into your uh, database. It could be a sequential database, or it could be any other database that you're looking for. Okay, it could be a NoSQL kind of a setup also. Okay, so now let's say that full database and feature repository is actually getting filled, coming into the data engineering point of view. Now you basically pick which data is needed to train the model. So that is your data sets that you're talking about. And what we talked about before was the experimentation and prototyping. That experimentation is basically wants to tell about what is the problem that you want to solve. Okay, what data I need to select, a bit about starting data exploration. Then if in case features are needed, the feature engineering that is needed. Then you do your model prototyping, that is your you create your pipeline of the model. Then you do your model validation, and this happens. And once you actually get the best model out of this experimentation and prototyping phase, it's an iterative process, right? And once I get the best model out of this, that trained model, I will now put it in the model registry, telling that this is my model that I'm putting. Apart from this, I will also have the ML metadata artifact repository, where I will be looking at what are the hyperparameters that are there. Like for example, some performance metrics of the model itself, like accuracy or loss, or any other thing. Like in segmentation, you have the dice loss. In object detection, you also look at that intersection over union. So different metrics and different annotations, all that you actually save it in the ML metadata and artifact library. So the trained model will be giving the model itself, The metadata and the other information of the model will be there in this one, and it's continuous, so you are actually learning, understanding and all that. So once this particular step is done and I know, okay, this particular, I found a model and I want to use it, then I do this version control where I'll stick to that for this config, use this code kind of a system. And now that particular thing, you have two things to connect to. One is your training operation, so that you will create the training pipeline itself, and you're also trying to do the formalization in terms of, let's say somebody used it in some different format, the other guy used it in different format. There should be a way so that there will be one particular format to be used, right? So all that particular thing you will do it in this training formalization, and the whatever training pipeline that you're creating, that config and code and all that, you will put it in the version control. So for data you have one repository, for model you have three things that are there. One with respect to the code and other with respect to the versioning of the code itself. Now coming to this is your ML development. Now what is the other one with respect to the ML thing? The other is the second one is your training operations. So we are trying to cover one by one, okay, in this, the bigger chunk that we are looking at, this one. ML development training, like that, 7 steps are there. No, now we are coming to, okay, now we are talking about versioning and training operationalization, what it is. So if you go little deeper in that, you also have the trigger of when I should run this pipeline. So that is your trigger. So for example, some config changes or something changes, the CI/CD will send a trigger to this, and that's where your operationalization will run. In the operationalization, you have three things. One is your continuous integration. So CI/CD is what? Continuous integration, continuous delivery. And the other part is your deployment that is there. So in your integration, you might have a build and testing kind of a thing. So let's say some config changes somewhere or some code changes somewhere. I need to make sure the updated code gets used in the uh, other particular stages, right? So I need to build again and do the integration testing, because after some changes, I need to see whether this is affecting the other pieces or not. So I do this integration testing. And once I know that yes, everything is fine, I need to put that into a repository to save that there is this change that happened and all that. And once that model and once that new code that is there is now proper, the code and config, now I will look for, do I need to do the staging? So for example, what to do is, starting only they don't directly use the model. There is something called a staging server and a deploy server. Staging server is like, think of like validation set. You keep validating whether it's working properly or not. And once you're confident enough, then you will put it in production or deploy, correct? So first what you do, I do a staging. So I do the staging with respect to the new changes that are there and see if there is any changes that are there and is it accepted. So that is called acceptance testing. So one is your integration testing here when the new code comes, and the other one is during the delivery acceptance testing. And let's say all the KPIs for acceptance are okay, then now I am confident that I can deploy my model. So I need to basically change that. So let's say staging server is in 10.0.3.2 or something. Now the configs with respect to the deployment server also will be similar. So yeah, so that you are testing in a similar environment. But there will be some changes in terms of deployment, will have little more in terms of processing power, maybe little more in terms of capability, maybe little more in terms of bandwidth and all that. So all that configs needs to change, right? So changing of all that is basically the deploy to production kind of a system. And once you put in production, you basically do your normal kind of a alpha release, beta release kind of a thing. So those are your release testing and also some smoke tests to see each of the models, are they working properly, or each of the modules that are there, are they working properly. So you might look at something like black box, white box, unit testing, integration testing, lot of things people do, and see the performance, everything is fine, the container deployment itself, is it fine, is it stable and all that. And once you know that yes, for all the phenomenon these things are good, then you have the release version of the training operation, and that will go and actually go and that whatever pipeline that you created currently, that is the training pipeline that people will use it for production. Any doubts here? Anything?
I sorry,
Yeah,
I had a doubt. So you're saying ML pipeline, right?
yeah,
These, we had some Azure course which Shiva ma'am asked us to check. So in that course, I was seeing inside there is an AI ML component inside Azure,
yes.
and I also read that it does auto ML. So do we use our own algorithm, or there itself we do all that auto ML operations and we don't? Is that the pipeline will get directly deployed from there, or we necessarily write a lot of code there?
No, 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 no. Don't write any code. The more code that you write, you are getting into more problem. That's why people are now looking into low code, no code. Okay.
Exactly. That's what is even advertised by Microsoft. So I was wondering, whatever we are learning now
No,
in
no,
the
no. This
algorithms,
is
right?
no, 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 no. So, for example, when I say auto ML,
Huh.
inside the auto ML, these things are there. So, you're trying to understand. Like, for
Okay.
example, I will come and tell that VGG 16, I can do classification.
Hmm.
Okay. Or I can tell I have set of images. I know how to classify using a deep learning model. All its statements are right. But in the beginning, on top, what it is, I can use AutoML for CI/CD. Is same as I can use a deep learning model for image classification. Both statements are similar in that particular hierarchy of visibility. Now, if I come one step deeper into AutoML, I will tell that there are these 7 stages of your pipeline. You have your training operationalization, you have ML mode, ML development, like similarly, when I come here, I'll say there are so many different flavors of deep learning models. I have VGG, I have InceptionNet, I have something for training like that. I'm trying to give the visibility or the depth in which you will understand. Now in the auto ML also, when I go a little deeper, okay, what is that CI/CD? When I should look into staging or when I should look into deployment and all that. So in the auto ML, all these things will be some config files. But I need to know the training pipeline that is stitched. Is it proper or not? For that to understand, I need to know this. You
Got it.
understand what I'm saying? I can have multiple different ways to create the training pipeline using AutoML. But not always the problem that you have at hand is there in one of those situations that is already being there. So think of it like you have some prototypes, prototype 1, 2, 3, 4, 5. Okay. The problem that is there at your hand is not fitting exactly into that prototype, but is combination of 3 and 4.
Okay.
Creating the combination of 3 and 4 pipeline, you need to understand that, right? How it is happening.
Yeah, true,
So
true.
that is where this is coming. So in case if the situation or the problem that you have at hand is fulfilled by one of the configs that are already there, you need not do anything. You just need to create the training pipeline and zip it across, and that will take care of the integration and delivery. But let's say there comes a situation where one of the existing configs are not enough. What to do is the question at hand. And the second thing also, not every code is bug free, right? Some issue will come somewhere in terms of, let's say, some log is not getting created, or maybe some testing is failing and all that.
Yeah,
Suppose you want to go deeper to understand where exactly it failed, you need to know this.
got it. And maybe this AutoML overall caters to standard problems, and if there's something very, very specific, you still need to have a custom code and maintain
Exactly.
that.
So once you come to a custom kind of a situation, you might use the existing modules, but you need to know how to stitch them together, right?
Yeah, got
So
it.
for example, I am trying to come up with a new, I'm giving the same example because I know you guys understood that. Okay. Suppose I want to come up and tell that no, 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 some new data set is there. I want to build a new model.
Yeah.
I know, okay, I know what is transfer learning. I can do transfer learning of VGG and do it. But just using VGG we cannot do, right? We need to create a custom model where last layer you are changing with respect to how many classes you have in the data. But that if you want to do, you will understand only if I know what is VGG configuration, how many layers are there, where I need to remove, what I need to put and all that.
Got it.
Okay, so that's the engineering aspect I'm talking about, not the science aspect of it.
Yeah.
All these stitching and all these the nuts and bolts that you do is more of engineering. That's why if you look at it, there are three engineering pieces: data engineering, ML engineering, app engineering. Okay, like somebody who is trying to do UI UX kind of a design. Okay, I want to create something new, let's say. Okay, and it's not a button also, it's not a radio button, it's not a toggle, it's not some drop down, but it is some new functionality, but it is combination of two things. But if I want to create that combination, I need to go into some JavaScript code or the HTML code to change that, right? Custom object. I don't know whether you're getting the flavor and the.
I got it. So because even if I see GC, Google Cloud and Amazon, everybody says everything is done by us. You don't need to do anything, right? So
That is why they are getting paid more, right? So, for example, I can, let's say Reva starts a new cloud service just because they have 100 GPUs and maybe 400 terabytes of memory and 500 terabyte of hard disk. Do you go and deploy a model there? You need all these things, right? You need all the capability of serving the model, doing a training operation, continuous monitoring, continuous deployment, prediction serving, all the services you need. Correct, right?
yeah.
That's where they're getting paid more. So if
So is it like we whatever programming we write, will it look different because it is written in AWS Azure? Like
no,
for
no. Only thing that differs is your nuts and bolts. That is your config files that connect the pipeline. Okay. So for example, the same code that is there. Say for example, you wrote some code in Python. Okay. So you created that thing, but it may or may not be directly deployable in the situation because maybe the target system doesn't have a Python kind of inference engine. Then what you will do, you will try to convert that whatever thing is there into the existing known kind of a setup, or basically repackaging the code so that you will have a different way of triggering the system. Then you will have a wrapper on top so that it will connect to your Python code. But that triggers that what you're getting, the metadata that you're having, the config files that you're writing might differ from how you implement in a AWS versus a GCP. But rest of all the things, like for example, each service, what permission you have, can you create a Docker, can I create a new image, can I add a new instance to it, where do I put the data, all the things are almost same in all the three. Only the pricing could be different and the kind of ML capabilities that each of it has might be different. And the ease at which you can implement could be different. But the crux of it is all same.
got it. Thanks.
Okay. So the third one after operationalization is your training. What do you do in your training? You look at any validation is needed, data transformation, you do the training, you evaluate and see whether this particular model is fine or not. That you keep doing until you have a retraining trigger. So retraining trigger will actually tell you, oh my God, the current model is not performing well. Take the new data that is from the data set and repository and do the training process again and put the training model in a model history. Now, the performance and of the model that is there previously, you need to compare, right? When you do the new model evaluation, that's why you are getting some data from repository, and the what new model that is created, what performance it has to go into the artifact repository. That retraining trigger could come from an app where app might user might tell retrain the model, performance is not bad, or it could come from the monitoring process that we will see. Okay. So pretty much the all the components you guys know, but I'm trying to put everything in a perspective, that's all. Okay. Even in the model deployment, what do you deploy? In the previous kind of training, now you put the new model in the registry, that is your trained model. Now I need to pick that particular trained model or the registered model that I have. I need to create that build, test and deploy to production pipeline. This is your CI/CD pipeline. So that I actually can deploy the model in the target system. So for that, I need to know what is the production environment. I need to know how does it look. So first I will put it in the staging, then I will put it in the production, and then I keep seeing how that particular, let's say the data is continuously flowing. I might do some kind of a online experimentation to see how the performance is changing. So this full process of build, test, deploy to production and putting it in the production environment, it's called the model deployment. Any questions? Okay, now if I put all the things together, what is CI/CD? It's continuous integration and continuous delivery. So it's combination of the training operationalization, ML development and your deployment putting together. And also you will have not everything you will put it in that. You will actually have a shadow deployment to see how good it is and all that. Then you will put it in the proper deployment. So these are for bigger systems. Why? Because suddenly a new model has come. I put that, I do a A/B testing, the previous model versus this model, how it is working, which use cases it is failing, what is happening and all that. Once I do all that particular thing, then I do the release. Suppose if I know that no, the release thing, whatever is there is not performing well, then there should be a rollback for me to go to the previous version. So this is such a complicated process per se. Now coming to the production serving, somebody was asking what is this serving, right? So once you deploy your model, all I have is just the serving package, right? Like this particular thing, you need to do the inference and all that. Now in the inference, I can do two types of inference. One is you might be looking for an online inference or a batch inference. What is an online inference? As and when the data is coming, I need to do the inference. Batch inference means wait for some particular time, then do the inference. For example, let's say I'm trying to do a IMPS kind of a transfer. It's more of an online inference because as and when somebody shifts puts the money, it has to go to the receive the target data or the guy whom you want to pay the money. While if you look at this NTG, what is that, RTGS and NEFT kind of a thing, it's a batch inference where RBI will schedule the thing every 30 minutes or every 1 hour and all that. Okay. Then streaming inference means I'm not even waiting for the data. As and when the data is coming, I'm actually streaming and getting the inference. Like for example, the data you have this the data that flows from your cable and gets onto your TV, right? It's a streaming inference. As and when it coming, it's actually getting streamed into that, right? And the other one is with respect to embedded inference. Embedded inference means you are that inference, whatever module is there, it's actually a small module that is getting embedded into that. So it's like a small piece of the bigger coin. So it could be just an embedded inference. Now in this model serving, once I deploy my model, once I get the new data, that is where you're trying to get, right? New data that is coming, I need to do the serving logs. So that is, these serving logs are the ones that will give to the monitoring engine, because the model monitoring happens based on the serving logs in terms of the performance and all that. So the guy who is consuming will have his server data that will actually get into this, like somebody was asking the client data and all that, right? And also the whatever predictions and explanations that model serving is there, that will go and get deployed onto app or whatever that model is using. So model consumer is the one that goes out as the thing. So this full process is called prediction serving. Then coming to continuous monitoring, I need to basically the serving logs that are there, I need to monitor three things. Very important. Data drift. That means my input distribution on which the model is trained is different from what data is coming currently to the model now. So they calculate something called the drift detection. Data drift detection. This is very important. And how do they calculate? A simple kind of a, you have the famous one being what is that called here? Distribution difference. What is it called? So one thing is they do distribution, distance between distributions. Very, very famous actually. Distribution difference. KL divergence. So they use KL divergence for this. Okay. So what is this KL divergence? So it's basically a metric that will give you the distance between two distributions. Okay. Think of it like distribution P is your input data and the distribution Q is your whatever new data that is coming. So that particular distribution, they have this formula. They will put this formula and they will see if it is big or small. And in case that, so it's a ratio between how divergent means how far apart they are. And once you know that this particular value is bigger, that means they are really far apart, then I know that the distribution that particular data is coming is different from on which it is learned. Then you will flag this, alert this, saying that data drift has happened. And that particular data drift alert will now come like a training trigger or that kind of a thing for other process. Okay. Now there is something called concept drift. Okay. What is this concept drift? Like for example, the concept is basically the mapping function between input and output, A to B. Okay. So now previously A to B was very simple kind of an equation, but suddenly some new things are getting added. For example, let's say in the beginning, I was looking at cat versus a dog. And later, I'm not looking at cat versus dog, but I'm trying to look at cat versus maybe a British bulldog and other dogs. So previously there was only two classes. Now it has actually become three classes. Now somebody will come and tell, no, in the cat also I have 1,000 varieties. I know the data for two different types of cats. Then it will be other cats. Those two different types of cats are two classes. Then British Bulldog is one class and the rest of the dogs are other class. So now what is happening? The concept itself has changed. Correct? So the number of classes itself has changed. And also second thing is the relation between input and output. So previously, for example, that stock market that they are looking at, right? Or maybe take a simple example of, I have some sensors that are there. I need to predict whether the machine will fail or not, right? So now I added a new sensor onto the machine. So the new sensor also is now giving the data, correct? But my older data is with respect to the older sensors that are there. So basically the relationship between when the machine will fail versus the existing inputs have changed, correct? So that is called the concept drift. You got understood the difference between data drift and concept drift? Data drift is with respect to inputs, the things are changing. Concept drift is with respect to outputs, the things are changing, or the mapping, the things are changing. Okay. Then there is this continuous evaluation. So every time the new data that comes, I need to continuously evaluate in terms of, okay, so previously I had accuracy as my value. Accuracy is not enough. I need to maybe look at recall or maybe precision. Or previously the situation was precision was important, but now recall is important. So your evaluation metrics also is changing, correct? So the way on which you are calculating those metrics also needs to be continuously evaluated, whether that is good or that particular thing is good or not, right? So the model monitoring has three things: the data drift, model drift, and continuous evaluation. And I want to know whether the labels change or not. For that I need to have the ground truth. That's why labels are getting inside this. And also whatever values or the logs that I'm creating, I need to put it in the ML artifact repository, because I'm trying to put the performance logs. Are there any anomalies? All that will put into their artifact thing. Okay. Now data drift, I need to have baseline statistics, right? Not every time I will come and do some distribution between input and output and all. There will be some representative or some particular code or formulas where things will be represented by input distribution. So you'll have some statistics around that also, right? And also some schemas and some relationships with that. Now we will come and see whether those relationships hold or not, whether that particular statistics hold or not, that kind of a thing. That also could give you the data drift and concept drift. So that is your continuous monitoring. Now coming to the next one of data and model management, this is one of the crucial thing. From the model side, I need to create all the logs that are there for the model in terms of monitoring, also in terms of serving. The second thing is, even in the data that is there, I need to create all the feature and other kinds of management that I do. So that is with respect to the data and feature management. Now metadata, so these all things are like what all the metadata that is there. So for each of the phase you have a lot of metadata, right? For example, I have hyperparameters for my ML model, I have statistics, I have evaluation metrics, I have profiling. That means whenever the particular ML model is being asked for evaluation, right? So those, when all it being inferred and all that, even the models itself, right? Different models, what is the kind of artifacts you have, the relationships and anything else. So all that is your metadata that you want to put. So all that you can actually discover, you can add, you can analyze, you can visualize, you want to export. There should be a possibility. So that is your metadata tracking kind of a system. And there should be a model governance. That means which model to use when is the model governance. So let's not go deeper, but I just wanted you to understand the flow or the kind of the complexity in which the ML systems are there. That's why, so people will say, hey, just learn about ML, man, you will get good job, you will paid more and all that. Because the ML system is this complicated and not everybody can do it, that's why they are getting paid more. Not that just given a data, I develop some, use some GitHub or maybe go to some Medium or some other article, get the code, run it and say, hey, done. I got the result. That's not the thing. I need to put it in production. I need to give it to the client. I need to take the requirements from the client and should be able to do this process to give to the client. That's where the full kind of value add will come whenever there is a new client that is onboarding, or even the client on which you are trying to see some changes and all that. So in put together, if I want to put all my ML ops together, I have the data and model management, which will take care of the repository and all that, the data set and features, right? The data sets, now you will use it for evaluation, experimentation and all that to get to the code and config that is there. You use training operations, you do your ML development and all that. That particular thing you will put it in your version control. Now you create a ML training pipeline using your operationalization, and that particular ML pipeline you do your continuous training. So you will look at the model artifacts and all, you will put it in the model registry. Take the registered model, you do the deployment. So you basically look at the serving package and all that. Then you do the prediction serving, which will generate the logs, and that logs you need to do the continuous monitoring. And this particular thing at every stage, it's actually bidirectional. So let's say during my prediction something wrong happens, that trigger will go into your data set with respect to anomaly and all that. That trigger will also get into your continuous training that I need to change something. Similarly, let's say in the monitoring engine something, maybe data drift happened, that change needs to alert my training also, that change needs to alert my data set also, that change needs to alert my data management model also, and that change needs to help me to do a new training and come back to the new model for deployment. Similarly, during my continuous training, let's say something happens, I need to be able to create the alert also, and also I need to basically put the registry or the model artifacts that I am trying to create. So this is entirely, if I would say, a 10,000 feet high or 10,000 feet high of what these guys, you call it a GCP or an Azure or AWS, they claim that we have an intelligent workflow. Google claims that I have an auto ML. Then our Amazon claims that I have a SageMaker kind of a system. What does it do? Maybe at the 10,000 level, this looks like this. Now what we need to do? go to each module, how the config files are there, how are they interacting with the other one, what are the kind of processes I need to create, what is that the synchronization I need to create. All that will be your for each of the use case could be different, right? So that's where your expertise will come into picture. Did you guys enjoy this? So first time when I saw this diagram, I fell in love with it, and I did not get a better diagram or something that can explain all these things.
Yes, sir.
Get
It's
it?
very comprehensive actually.
Yeah.
So I will share this link with you guys, and so you can just. I think you type this in Google, you will come, you will get it. So yeah, and this is the first time I'm actually covering ML ops for anybody. So generally I give talks and I do a lot of things, right? This is the first time actually I'm so in my team. I used to do for the people who joined newly and all, but this is the first time as people who are studying in terms of academia kind of a system. This is the first time actually I'm telling that ML ops. So recently ML ops courses started in some few IITs. Okay, maybe you can look into those kind of things with respect to that. That could be of real interest in terms of you want to enhance your skill set and all that. Yeah. Um,
One question I have, sir.
yeah.
So, do we have any provider who offers the packages together?
Yeah.
Because
Yeah. The GCP, AWS, and Azure gives it, na? So they name it differently, but they have the CI/CD pipeline automatically inside. Unless CI/CD is there, there won't be of any use. Like you develop a product, CI/CD is most important, right? In
right.
ML perspective, CI/CD is this. That's what I'm trying to say.
Okay.
All the three gives you support for CI/CD, and that's why they are getting paid more. So AWS is not getting. Maybe take a example of Azure. Azure, so let's say a new company is there, and I want to create. Previously, it was only infrastructure maintaining problem and all that. But now all these ML systems and come into picture. How many ML models I need to maintain? It's such a huge thing, right? And I also need to have a distributed version, and sometimes there will be some problem with respect to geography also. Let's say I am a Tata kind of a system. I have in Europe, I have in Asia, but the model that I developed in Europe, I may or may not be able to use it in Asia, because there'll be a lot of these security, there are 100 things that are there. I can use only learnings from that and not the entire thing. That's where a new system called federated learning is come into picture. Federation is what? Having a common problem, and now I'm trying to get the data from multiple people to understand the problem, right? So let's take one example of a credit card kind of a scenario. It doesn't really matter whether you are in HDFC or whether you are in SBI account or whether you have some other bank account. The credit score is completely a central kind of a thing, right? So now HDFC might provide only data about HDFC, and they don't have visibility towards SBI data. Similarly, SBI, why do they share the data of SBI customer? They won't. They will share it to some third party or whatever. But now I want to, as an aggregator, I want to know whether that particular guy is eligible for a credit card or not. That's where your CIBIL score or credit score will come into picture. And the learnings from each of the data and the frauds that happened in each of the bank, the failures at each of the bank, those could be used as learnings to create this, right? That's where it's called fed learning or federated learning. As a federation, as a group, I'm learning, but making sure that you are not breaking on privacy, you're not breaking on security. That's the new kind of thing that is coming into picture. Yeah, it's distributed also, and you're not sharing the data, you're trying to share the learnings kind of thing. In a glorified way, what are we doing? I'm not sharing the data, and I'm not sharing the data and labels to the new server or the new guy who is aggregating. I'm just giving the model weights to him. That's a more sophisticated way of telling that I'm sharing the insights rather than sharing the data. Yeah.
Got it, sir.
So can we go through that other one in terms of the notebook of autoencoder, and then I will leave it for open questions where anybody can ask any question regarding the course, regarding your doubts on ML, or regarding anything that you think that might be useful in terms of that, right? So, okay, first let's finish that notebook. So, can somebody who did not share till now, can somebody share your screen? Maybe Vinay, or Ritvik or Kathiresan did not share. Noor Fatima did not share today. Pravina did not share today. Srihari is not, you cannot share. So Srihari, we will leave him. These four, anybody who can share your screen can share your screen. I'll stop it now. And also, before we start, I also need to know the feedback about the course in terms of like for example, okay, maybe we will do that later, but let's stick to this. Can you reduce the left hand margin? The left hand margin where you have all this data system and all that. The data, yeah, that organization, you can remove that, yeah.
No, it's not. I'm not able to remove, sir.
Oh, okay, okay, can't reduce, is it? Okay, no problem.
Yeah,
No,
there's
no, leave it, no problem. Okay. Now, Kathiresan, you need to tell what is the problem at hand, what are we solving, how are we going? Yes, all yours. You need to tell to your class. Yeah.
okay. So again, this is also a time series problem to predict the anomaly in terms of price sequencing using the LSTM autoencoders. So we have the data is of GE stock price for about like 18 years of data of GE stock price is there. Based on that, we need to predict the anomalies. Okay.
Just one small thing. Can you go little up, little up, little up? Where you're talking about the GE's data. Yeah, yeah. Just wait there. So now, basically from 1985 to 2013, these 18 years till September. Okay. Third, there was no anomalies. So all the data till there is normal with you.
Okay.
But now I am trying to look from 4th September 2013 till 2020 to see is there an anomaly or not.
Okay. Okay. Got it.
We are
So,
assuming that there was no anomaly before. Having that assumption in mind, now I want to see 4th September till 2020, is there any anomaly or not? Okay.
Okay.
Yeah.
Okay. So here we are inputting the required libraries, and this is data read. We are reading
So
data.
you need to go a little slow.
Sure.
The Keras layers that are there below, they're not straightforward. Okay. So the
Okay.
Keras layers previously, what all things we saw dense, LSTM, dropout, repeat vector, time distributed, flatten. So the same things now they are using here, nothing else. Okay.
Okay.
Yeah.
So here we are reading that data what we have at hand, the G's data. So it has several columns with respect to its price.
Lowest price, highest price, opening price, closing price,
Yeah.
like that. Okay.
Yeah. And the volumes.
Adjustment. What is that adjustment? So people generally what they do now, at the end, they do some can come little right. Uh, they do adjustment to the stock. I don't know for some reason. Okay, if somebody who is having finance kind of background can tell us. But the last one is important, Kathiresan. That is your volume. Volume will actually tell you how many shares or like how many shares have been bought or how many shares that interaction is there or how many people are, I don't know, people or shares, but it's about the size or the kind of scale at which things are happening, right? That's
How
the
many?
volume.
Yes, the volume transactions basically at this closing price.
So it could be like how many shares have been bought or how many shares have been like sold or something like that. All them put together will actually tell you the volume also. Yeah. Next.
Okay, so we are reading the data and we are fetching only the date and the closing price of it.
Be faster. We saw it in the previous thing.
Okay, fine. So
Yeah.
we have around 9,075 records
Okay.
in our data frame.
Mhm.
So here we are trying to visualize the time series.
Yeah.
Okay.
So your y-axis is your dollar kind of thing.
X is date and Y axis is the closing price.
Price is in dollars, no?
Yes.
Okay.
And here we are, I mean, splitting the data into test and train. So
Here
so
the it is based on the date because we
date,
assume
yeah,
that till 3rd September the things were fine.
fine.
We want to check on from 4th September onwards what it is. So this also could be a way to split your data given a date, right? I can break it, or if I know 80-20 kind of a split there, we used to do that, but now it is like date based splitting currently. Yeah, go ahead.
Have split the data. Then we are standardizing the data here using the standard scaler. And so here
I'm creating the timestamp.
here creating the time series time steps.
Mention same thing, 30 only time steps. That means month before only you're looking for.
Okay. Okay, here we are just printing the shape of the train and test data.
All others were able to do it, guys. All the others were able to execute it. Everybody.
Yes, sir.
Okay.
Okay, we are just checking the closing price of the train data. Yeah, now we are performing we are building the model. The model is built using this sequential class. We are adding an LSTM layer.
28 is the output. Yeah.
Yeah, and then the dropout is 20%. We have a repeat vector to repeat the input.
Little right actually. Can you go little right?
Yeah.
So because we want the output shape to be 30,1. Why? Because they're giving 30 as the input
30.
and every time you need to know. That's why you are having this repeat vector. So you'll give each vector and you will actually repeat it 30 times.
Okay. Then we are again.
Sorry, I couldn't understand this repeat factor.
So now what is happening is repeat vector will repeat your input. So now what we're trying to do, we want to repeat the input 30 times. We want to repeat our vector 30 times. Why? Because that vector whatever is there, so if you come little down, that LSTM, that down, that what is being shown. Wait. So once you do dropout, right, I get 128 is my output shape, right? But what is my goal? I need to basically look for 30 values, time distributed, and look for that bins and all that and see if there is an anomaly or not. So I need to get a vector which is 30,1. That is my idea in mind. So, but if I just go through LSTM, which will take a value, whatever value that is there, and input output shape is 128, I will get none comma 128 only as an output. But I want to send that particular thing 30 times I'm repeating. So that I will get each time when I repeat, I will get one vector out. So at the end, for each vector of 128, I will get 30, 128 as my output. So it's like in the time you're trying to do 30 times, you're basically repeating. So think of it like I have 128, none, 128 that is coming. Now create 30 layers and now you send the same input to that.
Thank you, sir.
Okay. Again, one more LSTM layer with a return sequence true has been added.
What's the time distributed?
Time distributed. No idea, sir.
So time distributed layer is basically you are now, so come little down. Yeah, just wait there. Okay. So now the 30, 128 is there, right?
Yeah.
Just 1 minute. Okay. Sorry for that. Yeah. So now I have 30, 128. Okay. But what I'm trying to see, that 30 vector is actually what to say, the 30 is representing the month, right? So I can actually look at every week, or I can look at 1 week at a time, or I can look at different ways of splitting the time distributed thing, correct? So if little up, little up, little up. So and a little right on that model.add, there is one right. So applies a specific layer such as dense to every sample it receives as an output. So what is happening, that 30 is basically the LSTM will make sure that you will look it into as a time series kind of a thing. But the 30 what is coming, I want to basically look at distributed version, like maybe 5 at a time, 4 at a time, 10 at a time, 20 at a time. So that particular capability. So dropout is one thing which will actually you don't have control. You just tell 20% and that gets switched off. But time distributed will make sure that all the things that are dependent on time will be looking together, right? So now for each specific layer, now I have 30 layers of it because I repeated it, right? So I have the same input I repeated 30 times, so I have 30 versions of the same thing. If I look at that glorified one, but 30 I don't want to take at a time. I want to basically look at 5 at a time, 6 at a time, 10 at a time. Means what? Basically I'm trying to look at 1 week at a time or 2 weeks at a time kind of thing, right? If you want to convert the 30 into the days kind of thing. So this time underscore distributed will help you to sample and see for each of the layer that is there. So the 30, 128 that you're sending, the full 30 it may not use. It might use only the first 8, or it might use the second 8, or it might use only the third 8 or third 7 or those kind of things. Okay. So that particular aspect or the capability is there with respect to the time distributed layer. That is to make sure that you are whatever 30 times that you replicated, you are actually getting one thing out, and that particular thing you are trying to do the bin and get to see whether there is an anomaly or not.
Okay. Okay, so the model is compiled with the optimizer as Adam and LAS as mean average error. Okay, here we are just printing the model summary. Then here we are training the model with 100 epoch and batch size as 32 with 10% data for validation. Okay, so we have a early stopping of value loss and mode as min with patience as 3, so it has to wait for at least a minimum of 3 epochs. to see whether I mean the value loss is value loss stops improving, or I mean this particular metrics is
You are
not
monitoring the validation loss.
validation loss, and if it stops improving, we need to stop, perform a stop. So shuffle false, I'm not sure what is it.
So you are not shuffling the data because it's time series, right?
Okay.
In a normal kind of a scenario where you're doing classification and all that, you used to shuffle the data because for you ordering is not important there. But
Okay.
in
So
this case, that the ordering is important, so shuffle should be false. By default, shuffle is true. That's why when
okay.
you use false, you need to explicitly mention.
Okay, got it. Okay. So it performed around 9 epoch. Then here we are just plotting the training loss.
Training loss is in blue and
Validation losses
is in orange. Okay,
orange
so
color.
patience was 3. That's why at 6 you saw at 7 and 8 and it did not change. It increased. So what did you do? I stopped it. So the model that is there is actually the performance so here you did not save and all. So you will get the output only at 8. But if you had used that last time we saw that, right, where you can save the model before the patient stops, right, starts. That also could be used to make sure that you are saving the 6th epoch's values or weights.
Okay.
Come down. So now the same thing, I need to find the threshold. That's where you need to determine the anomalies. So what do you do? I predict on the train because we know that training samples are the normal samples.
Normal one.
The same strategy. Only thing is here, instead of using the normal convolution, they use the LSTM. That's why it's called LSTM autoencoder.
Autoencoder. Okay.
Yeah. Now in this case, the threshold is the come down. Where all it stopped? My threshold here. It went till
19.
So here, because the spread was too much, what they did was they looked at that. If you come little up, they looked at all the error samples which are below the come little up, which are below the 85 percentile. That means all the 85th percentile they took the value and that they put all the values that are lesser than that as the normal kind of a error threshold in this case. Okay, come down. So that particular 85th percentile is the value is 0.19. So that's what they are getting. 0.19 is the one where 85% of the percentile kind of a thing. Okay. So now if you come little down, that is they set it as a threshold. Now if you look at the test error, you are actually getting come down. You are actually getting little more. So now you need to no down. So now you need to basically look for how the test loss is there with respect to the threshold. Come down. Then is there any diagram? So now you see when I put 0.19 as my threshold, you have some of the points that are there on top, right? So that is your test losses. So all the things that are above your 0.19 are your anomalies. While all the points which are below the threshold are the normal points. So now he put that test score of anomaly equal to true. He just set it and now he is setting wherever the values are higher that you set the anomaly as true.
And then we here it is just
Now you're trying to visualize it. Okay.
Yeah.
Now they removed reconstruction loss and they directly put the close price. And where all you have the anomaly, they just try to put the dots. So the anomaly basically means where there is a sharp down or a sharp up. In another way of that. So compared to the 30 values of that particular month or the previous 30 values, if there is a sharp change in terms of up or down and if it is little continuous, That's where you term that as an anomaly.
Okay.
Okay. So now, okay. So now I will actually open for any open questions that you have. Or in case if you want guys want me to cover some topic, I'll try to cover the topic. Or in case you have some questions, we can take the questions as well.
Sir, I have one question on the dimensions of the input and the output layers and the intermediate layers as well in general, sir.
Of convolution or?
Convolution, yes, sir. So in general, I mean, if I need to create one model myself just to understand and learn the basic concepts,
Uh-huh.
so how the dimensions flow in and output, you told that based on the data size, I mean dimension of the data, output will match that, and the input will also match the data, which the input layer dimension will also match the dimension of the input data.
No. After you do the pre-processing, then there'll be one input data size, right?
Right.
That should match to the first layer that you're trying to give for the convolution.
Okay, and the last layer output that should match the class sizes, the number of
Yeah.
classes.
Correct. If you're doing a classification problem, yes. Okay, maybe I will open one of um the convolution thing that we did, right? I will open that and we'll see how to get that. Okay, just a minute. I'll try to. The CNN only it is there. I'm trying to see if okay. So this is one thing that I think it will be useful. Can you see my screen, guys?
Yes, sir.
Can you see my screen?
Yeah.
Okay, so forget what we are doing. We are just trying to do a CIFAR 10. That is your 10 classes CIFAR images that are there. We are now trying to see, I want to construct a CNN, right? So I loaded my data. I formatted my data, did all your categorical and all that. But now comes, how do I build the CNN? And that's the question, right? So now it's a sequential. Now I know that this particular CIFAR input is 32, 32, 3.
Yes, sir.
CIFAR values are 32, 32, 3. So I put that 32, 32, 3, right? I don't change anything. But all I know is as and when the convolution, whatever layers are there, I need to make sure that the sizes decrease, correct? So now the question comes is this thing. So how did I choose it is 32 is the question, correct? Na here, filters. Is that the question you're talking about?
Yes, sir.
Okay, so if you look at this, right, our first layer is a convolution and it specifies 32 is your feature map, 3 cross 3 is the kernel size, and my input size is 32 32 cross 3. And if padding is same, that means my input spatial dimensions are same as the output. So what they tried to do is, so this particular whatever 32 32 3 that they gave, now I am using 32 filters and 3 cross 3 as a filter shape. And since I put padding as same, I will actually get the same value 32 32 in the next stage also. And to make sure that there is no overfitting, he just put 20% as nodes as 0. That is your dropout. Now he did a max pooling part of it just to make sure that this reduces by 2. And you did the flattening. So once you do the flattening, now you will need to know how many nodes are there to that shape. So one small thing you could do, Soumya, I will send you this link. Can you execute in the notebook?
Yes, sir.
Only the CNN part, not the data part. You can share your screen. Yeah. And we'll take this exercise till 4 and 4. I want to guys you to ask all the questions that you have in your mind.
Yes, sir. I'm sharing the screen.
Yeah.
Should I copy this?
Yeah. And make sure you put all your the model and all that. You invoke all the models and all that. And then you can go there to that code. You might get this one. No, the remove the line numbers and you can go to the code. Is there no, you need to remove the 2, 3 and all.
Sorry, sir.
You need to remove that line numbers.
Okay, sure. I'll do that. So, is there any? I'm looking at any way to download this.
Can you see that? No. Can you go there? There is one. Go up to that model block. You can see on the right. If you go, there is one sign there.
Yes.
Copy that and paste it there. So that's the best way to do it. So that you won't get. Oh, they are getting the line numbers also. Then this is really. Here, remove that. It won't take much time. Yeah.
Sure, sir.
In the same file, no, 1 minute, same file, the same link that is there. Click on that. Now go up. There's this .py on top.
Okay, sir.
Click on that. Now you copy.
Yeah, this is without numbers.
Okay. Now you do it only till file. File also you can put it in the next one. You just need to only till model.add. Yeah. Yeah. So now can you do model.summary here? Yeah, I think you need to do tensorflow.keras or something like that. Remove SGD. We don't require SGD now. Just remove that for our thing. Correct. So if you come here, simple. My input was 32 by 32 by 32. 32 by 32 by 3. Correct na input. Input was 32 by 32 by 3. Correct.
Yes, sir.
Everybody, are you following? My CIFAR input is basically 32 by 32 by 3. And we know if padding is same, the size is same, it's not going to change. So 32 by 32 will be still 32 by 33 or 32 only. In case if you put if you remove the padding and the filter size is 3 cross 3, then you have to subtract by 3 there. That's all. Now, if I'm using 32 filters, that means wherever that filters is there, that filters is your channels, right? It will go and attack there. So if you come down, after my first layer of 32 filters, I should expect the output size to be 32, 32, 32. Am I right?
Yes, sir.
Come down. That's what you see here, 32, 32, 32. Okay. And now, can you go a little up? If you look at the next convolution, I'm not doing padding is same. Padding is valid means basically you subtract that and whatever you get is the thing. So 32 minus 3 is 29 plus 1. That's what we learned, right? N minus P plus 1 divided by the stride. Yes, stride is 1 by default. Correct? So 32 minus 3 is 29 plus 1 should be 30. So my size should be 30 cross 30 cross 32. That should be my size after this convolution layer. Just check that. Correct na? 32, 30, 30, 32. Correct. Now, when I do max pooling, I know that it will divide by 2 factor. So suppose if it is an odd value, I will reduce. So let's say it is 29. Then I will do 29 divided by 2, which is 14. Right. Now it is 30 by 30. So if I do max pooling by 2, the 30 will become 15. The second 30 will become 15. Right. Divided by 2. That's what we do, right? We take the 2 cross 2, take the max value and put it there. So the scale by 2, the scale by 2 will reduce on both sides. So if you look at the down, if you look at the shape, it will be 15, 15, 32. Right? So that is your output. Now I want to flatten it. What is flattening? Putting everything in one dimension. So 15 into 15 into 32, how much does it give you? Can you calculate that? 15 into 15 into 32. Just one more cell. Just calculate 15 into 15 into 32. 7,200. So once I flatten the layer, the 15 into 15 into 32 will now become 7,200. That is your output. Now what did I do after that? I added two dense layers. One is 512. The other one is with respect to dropout is anyway not going to change. And the next is your dense layer of 10. That's what I tried to do. So that 7,200 what is there, if I add dense 512, my output is 512. Correct, right? Now that 7,200, my right side is 512 nodes. I'm trying to have a dense layer. That is a fully connected layer. So 7,200 on the left, 512 on the right. So my output is 512. Can you come little down? Show that sequence. So you will get 512. And my next dense layer, which is my last output layer, I put 10 as my number of classes, right? So that 512 is there on the left and 10 classes is there on the right, which I need to do the classification. That's why it becomes 10. Guys, clear with this?
Sir, in this 7,200 on the left and 512 on the right, that's why the output is 512.
Correct.
Okay.
Because it's a fully connected layer. 7,200 is coming from the left. That is your previous layer. And in this layer, I have 512 nodes. Dense of first is your nodes, number of nodes in the dense layer. Okay. Now, does it clarify?
Yes, sir.
Anybody, any questions regarding this or anything else? Thank you so much for asking question. You can stop sharing and I'll ask others. Any other questions regarding all the things that we studied? Yeah, Sandeep.
No, I mean, I mean, no questions though, but just that we'll have to do some practice to kind of get a hang of it. That's it.
Yeah. So I would actually tell you, okay, the more amount of time that you spend, the more you can master in this. Okay.
Yeah, exactly.
The second thing that I wanted to tell was, I know it's a very heavy course. So if you have seen the previous courses, maybe I'm not sure what courses you went through. The topics, some of the topics you knew already, like you are able to get hang of it or able to relate to something or whatever it is. But this is one course where, at least for me, when I started in the beginning, all the topics are new. Like for example, I never looked at what is an optimizer, or I never looked at evaluation function. I had learned in ML, but hyper parameter optimization, then regularization in terms of dropout, or convolution neural network itself. For example, the neural network concept itself is new to me.
Yeah.
And the CNN in terms of spatial is new to me. The RNN is new to me. The time series forecasting is new to me. Forecasting I did using ARIMA and all that, but using with respect to LSTM, the concepts are new to me. The forget gate, the input gate, all that was new to me. The context, the state of the cell, it was new. And coming to object detection itself, I never worked on any object detection in terms of I need to find an object or I need to find a bounding box or even the segmentation, never in my life. So all the concepts that are there are actually new and it takes some time to digest and assimilate.
Yeah.
But all I can tell is if you are able to go through the video that is there in the class and go through the PPT, and if you have any questions in any of the slide of the PPT also, and also in any assignment or anything that you have, or if you have some problem at hand, like suppose I'm trying to solve some problem and I'm actually stuck there, please feel free to reach out. Okay.
Yeah.
Not a problem at all. Anytime I'm there to help you guys. And I'm there over LinkedIn as well. And I'll actually share my email ID. Don't spam it, but in case you're like having a genuine kind of a question, please reach out. And I'm anytime, maybe not that I'm like an online streaming kind of a inference I will give. Maybe I'll give like maybe a batch inference, or at least by end of the day I will try to send something. Okay. Anything else, anybody? Any questions that you have? Anything on ML?
Actually, I was about to say the same thing that Sandeep said. It's very difficult. It's very, very dense compared to the other
Yes,
topics we
it's
had.
intricate, I understand, and that's
So
why
the one thing is that it's still very difficult to visualize this convolutions, like what these steps are doing, dense, etc. No matter how much, as he said, maybe more we do, we get a hang of it.
so if you, yeah, agreed to
I
that.
was just trying to understand, knowing the intricacies of it. Like then the next step would be to understand which one to use where, right? Like
Yes.
only if we understand that intricacy of these networks, we'll know which one to use where. So we are, we are not yet there. I believe we are still in a step where we are trying to understand what is ReLU does, convolutions do, RNN, LSTM.
No, I
So
completely agree with your point, and I empathize also, because, for example, it took a lot of time for me also to digest. So, for example, a lot of the content might be there in some Stanford or maybe some other sites and all. I try to get the best of the content that is available and most visualizing kind of a content that is available in market. So for me also, gathering this also took a lot of time for me to understand. Like, for example, if I want to show convolution, I can show it like this, or I can just put some text and show it, right? So these are some of the slides I tried to take it from the existing, like Stanford, then UCLA, MIT, those kind of courses where the best that I can actually give it to you guys, I try to give the best. Okay. And it's heavy, I know it's heavy. That's why these guys are getting paid more. You got what I'm saying? The So for example, currently the guy who knows, so think of it like all the material or all the um equipments that you have in hand, maybe a hammer or the chisel and all that. For that task, what to use, like exactly what Shivpriya is talking about, the guy who knows which instrument to use when is the guy who gets paid more, and the faster he does it, he gets paid even more. So for example, the design choices of when to use what, that will come into picture only if you understand that concept, number one. Number two, try to do the AB kind of a testing. Like, for example, okay, in this scenario this works well, in that scenario this works well. So if you have that landscape or the understanding of yeah, till that extent, then only you will know which one to use
yeah,
when. Right? Yeah. I
and
can
the and the point which
completely empathize. Yeah, yeah. Tell me.
yeah, the point that I try to make, saying that you have to understand also, is that as you mentioned, we had classes earlier for stats and linear algebra. But I'm afraid that we didn't cover this from a mathematical perspective, right? Sort of, because when I was trying to do the assignment and I tried to take a reference, right, they were talking about translational invariance and scaling and stuff like that. There's not much in depth we covered with respect to ML. We covered some, but we didn't cover it with respect to deep learning. So if you can give us or point us to some resource where we can try to understand, like, what is the purpose, for example, what does pooling do from a mathematical perspective for this computation, so that
Sure,
would be
sure.
very helpful.
Yeah, yeah, I can send the link right away. So I have like there are some books actually which will tell you the mathematics behind the deep learning, like that. Okay. I will, maybe I'll share the link here itself. Let me figure out where that guy is there. Um, so for example, the CNN that you're talking about, right? The convolution neural network.
Yeah.
It's translation invariant. Why?
Exactly. So all
Right?
this
Because the cat, it could be in the left side of the image, or it could be in center of the image, or it could be in the right of the image. It doesn't matter, right?
yeah,
So
but how does that do that? Is like how us writing those 10 lines conv 2D dense, how does that achieve? That is what I was trying to understand.
okay, okay. So for example, I think I got you what you're trying to talk about. Okay. So let me actually show this. Okay. Then we will see what does it come to. Okay. So this particular thing is a okay. I'll just try to CNN. Is the CNN? Okay, maybe this is the best figure that at least I can show it with. Okay, take this for example. Forget all the content that is there inside. Take this as a CNN that is there with you. Okay, Shivpriya, right? Yeah.
Yeah.
So let's say this is the image, right? And can you see my cursor that is moving?
Yeah.
Let's say the cat is here. This is the full image. Okay, I'll try to use the this one. Screen title. What is it, man? Pen color. Okay, so let's say the cat is here. So this is your entire image, this full image. This is your full image. Okay, can you see my screen, guys? This is very, very important. Like what she has asked. Okay, the maths behind it. And I'm a mathematician in like I did MSc maths, so I know the thing that is happening. So this, let's say cat is here. Cat is here, the small corner on the left. So if you come to the convolution, that guy will come here, right? If to the convolution, that guy will come here. To the convolution, that guy will come here. That's spatial in nature. And once you do the, what is that called? The flatten and all, maybe that block could be somewhere here. This thing here. Okay. Now that guy will come to here, that guy will come here, that guy will come here. Right? This translation, it doesn't matter whether that cat is whatever. That cat, let's say this is my cat class, that guy, that highest amount will come here only. Now let's say I have cat here. Or maybe I take the extreme right corner, the cat here. The extreme right corner of the cat here will give the activation function here because it will activate those neurons that particular class is there. Similarly, it will come here. It will come here. Okay, at the topmost. And maybe this thing is mapped here, so it will come here. But the beauty is when I come to this thing, again my output will come to the cat class only. Why? Because we are trying to look for presence of an object. We are not trying to see where is that object. Correct, na? Once you come to where, you will look into object detection, bounding box and all that. We are now trying to look for is the object present or not. So is the activation happened because of cat? Is the activation happened because of cat? Is the activation happened because of cat? All that, the 2D and all that. So 2D will, that max pooling will, what does it do? The highest amount of activation it will take because that will be the strongest present of the object. But once you come to fully connected, the last one will actually relate to the cat class, which has the highest output. Because this particular object, it doesn't matter whether it is here or here or here, but still you are getting the same output. That means what? So what you move here is actually called the translation. Okay. So translation is what? A simple thing. So f of x and f of x plus c, it's not changing. Though the x is now changed to c, right? That is called translation invariance. So if you look at this particular object, whether the cat is here or here or here or anywhere in the image, my classification did not change. It's still same. That's why there is a translation invariance property. Now, if you come to scaling, to a certain extent, suppose for example, I blowed the cat so that it will be more than the image, then it will be difficult. But let's say a bigger cat versus a smaller cat, still it will actually tell the cat is there or not, right? Scaling means f of x is same as f of maybe some a into x or b into x kind of thing, some linear scaling. So it doesn't matter whether my cat is of this size or whether the cat is of this size, still I'll be able to tell that it's a cat. That's why it is spatially invariant to certain extent, because if let's say one of the leg goes out or something goes out, we don't know whether you'll be able to get the cat or not, right? Now coming to translation and this, now take the rotation. So if you remember your augmentation, right, we tried to do rotation, correct? Take the image, rotate and still put it as cat only. Why? we want to make sure that the cat is sleeping or cat is rotated this, or that guy taking image is taking this way or this way or this way or any other way, still the cat should be detected, right? That's why that augmentation of different angles and still putting that into class, cat class, is helping you to detect cat in each angle that is there, right? So there is a rotation invariance to certain extent where augmentation is happening. So in that way, you can go as deeper in terms of that. So for example, at the end, this is a dot product. So convolution is a dot product, and it is dot product with respect to that particular size or that particular place or that particular spatial location. So the dot product, it doesn't really matter whether the cat is here or here. The dot product anyway is going to multiply that much extent. It doesn't matter where it is there. That's why it is linear invariant. Does it answer your question to certain extent? I will share the book, but what I wanted to say is, so last time what happened, the last batch that was there, I went little deeper into the math and people just got lost, and that's why this
No,
particular batch,
actually, I'm feeling lost without the math, right? That's why I was
so
asking.
you are
I don't know
having
what
that
is happening inside.
exactly. So you are exactly having the complementary problem of trying to get this, but it's good. So for example, what I would say is appreciate that, okay, this is what is happening. Try to do some exercises. Now go deeper. Like for example, if you go to explainability or those kind of parts, unless math is there, you won't understand what it is happening, right? You need to go back. You need to do deconvolution. You need to see which layer is picking what part of the object and
Yeah.
all that particular scenario. Math is the most important thing. And if you look at anything that is happening, it's a linear algebra. The dot product, it's a linear algebra. The max thing that you're trying to do, it's a simple calculus that we studied. Only thing is this 2D to 1D, it's a linear transformation. Correct. So see, 28 by 28 for me is same as 28 into 28, whatever value that comes. For me, it is same. Like for example, if I'm trying to look at the object as 10 by 10, or I'm looking at an object of 100 cross 1, for me it is same. If I'm just doing a dot product.
Yeah.
Correct.
True.
Doesn't really matter. But convolution, what does it do? It will help you to reduce the number of parameters. If I take 256 by 256, if that many pixels are there and if I keep calculating dense layers, the number of layers in which I should learn will go for 6. And the second thing is I'm not learning the spatial sharing, and reducing the number of parameters is the crux or the beauty about CNN, right? So that's where I'm trying to reduce the number of parameters. So in one way, I'm trying to look for solution in a lower dimension space.
Correct. Yes.
So in that way, so everything we can map into that, like even the optimizer, when you're trying to see, I'm trying to look for a decision function which has the least kind of a value. And I'm using gradient to go there. It's a simple calculus.
Yeah.
I'm trying to use a gradient. I'm trying to do a little bit of accelerated gradient to go there. So I'm having this kind of changing learning rate so that I have a say into whether to go faster or lesser kind of thing. It's a simple physics kind of a momentum, but you're trying to have a scaling factor in terms of learning rate. So
Yep.
any aspects you go, it's basically three things. One is your linear algebra and the other is calculus. Why? Because you have, when the gradients are going back, you're trying to do the dot product and go, you're trying to do
Correct.
the,
Yes.
what is that called? The
Back
differentiation
propagate.
chain rule and go there.
Ah.
You're trying to, at the end, it's a chain rule, right? The component in this particular thing that is coming from the front layer into what is the contribution I need to give to the next layer. It's basically the chain rule.
Yeah.
It's getting multiplied and going. So the gradient itself or the learning of the neural network itself is on math. It's a chain rule that's happening. Right. So you
Yeah.
take that extent, right? We can go to 100 different ways, and actually you're doing the entire thing is on calculus and linear algebra. And to a certain extent, yes, I agree. If you use like complicated error surfaces or you're trying to use a complicated representation and all, it will go a little bit of manifold and maybe like a non-linear transformation or non-linear algebra kind of a stuff.
Yeah.
But we are not at there. We are not going to any complicated kind of a thing. you can visualize and say that this CNN layer is trying to get into some manifold and doing that, something like that. But we need not go to that extent. All we need to see is, okay, when I'm going forward, it is my dot product that is taking me. When I'm going backward, it is a chain rule that is taking me.
Yeah.
And all the invariance properties that I learned in math, the linear algebra, and the transformation. See, for example, is a matrix transformation that's happening, right? Like any of these things. So the matrix products are happening at the end, and I'm trying to go from one dimensional space to other dimensional space. If you look at the auto encoder that we learned today, we went from a 5-dimensional space to a 2-dimensional space. So think of it like I'm trying to look for a compression kind of a scenario. Can I have the 5-dimensional, whatever that object is telling, can I explain it in a 2-dimension? And that 2-dimension, I know that it is possible because those 2 dimensions are much more independent than those 5 dimensions that are there. So all the dependencies that could be there, or some kind of correlations that are there, I'm trying to remove and go into a more of a independent kind of a dimension, to make sure that with lesser representation, I'll be able to get the same kind of a stuff. So if you look at this, right, everything is your calculus and linear algebra everywhere. You take a thing like, for example, the concept of subsampling. What does it do? Subsampling. You are having an image of 10 cross 10. I need output as 5 cross 5. What does it do? It just ignores every alternate thing and remove and put that thing, right? Or it can take an average value and put the value, right? So what is happening there? You're basically doing a linear transformation.
Yeah, got it.
Correct. So everything that you see is actually the fundamental is, I won't say linear transformation, but transformation is happening. But because activation functions are jumping, it's a non-linear transformation. Simple.
Basically, that activation functions are like the kernels in SVM. It is doing a nonlinear
Kernels in
transformation.
SVM where it is projecting where, so for example, it's reducing your output also, size also, and also trying to give more importance to where the maximum kind of a thing is there, right? So
Yeah.
it's non-linear in nature. Okay. So, and the other kind of things. So for example, whatever I tried to cover, the same slide, now I told it in a mathematical perspective, right? Now, if I ask other guys, so out of 10 guys, if I ask you, did you understand? People who are passionate about maths, yes, they will understand. But people are like, for example, I'm not this class, I'm just trying to talk in a general scenario. For them, give me the tool where I can do this thing. Tell me CNN so that I can do classification. Tell me those layers where I can build a particular network. So if the intent itself is in that aspect, then if I come and explain in math, then everybody will be switched off, right? But if I'm able to excite you guys, if I'm able to make you guys open this slide again and see it and see what the hell is happening inside, and how the magic is happening with respect to, I'm able to get that classification just by putting some set of filters in hierarchical fashion. What is happening? So if I'm able to excite that interest in you and be able for you to open or maybe explore or maybe able to experiment in a different scenario, my job is done. You guys are getting my intention. So my intention is not that, okay, Shivpriya or Soumya or some rest of the people like Pravina, 100 people are there, let's say in the class. My intention is not that Shivpriya understands everything in this slide or somebody else will understand everything in this slide. If I am able to make sure you open this slide after the class, my job is done as a kind of helping you guys. Okay. If I'm able to give you that particular excitement of, oh, I did classification using this. I want to do it on my data. How do I do it? If that particular excitement or the interest that comes of your own and able to experiment with whatever things that we are learning, my job is done. So all I am here is to make sure that you enjoy this journey as well. And the second thing is with respect to, you are able to experiment with what you studied also, right? Once you put it in practice only, you will be able to appreciate and enjoy it and also get to know the hang of it. But definitely, Shivapriya, I'll try to share the link of that book with you, and maybe that could help
That
you to
would be
give.
very helpful. It's because half of it is going over my head without understanding why it is there. So
Yeah, and second thing, right? Like for example, I will tell you. Okay, I don't know. So, okay, guys, so it's time to switch on your videos. I don't know whether we had interaction with that or not, but if possible, can you switch on your videos so that our interaction will be a little more beneficial and uh, more one-on-one kind of a thing. So what I'm trying to say is, so let's say I'm nowhere. My intention is not to put you off or something. I'll share the thing, but I will tell you the funda also. Okay. So if my intention was to learn a cycle,
ಅವರು
Shivpriya,
ಇವತ್ತು ಬರಲ್ವಂತೆ. ಇವತ್ತು
people who
ಬರಲ್ವಂತೆ.
are Srihari, you can mute for some time. Okay. So Shivpriya, I just wanted to tell this. So if my intention was to learn a bicycle, right? My intention is to learn the balance first, buy the bicycle, learn the balance, right? And once I'm actually an expert in the bicycle, then I will learn in case, let's say that tire broke, let's say there is a puncture or there is some issue with respect to handle or there is some with respect to something, or I need to add one more seat to my cycle. That's where you actually take a step back and try to understand little more into which component is reinforcing what, which how that thing is happening, or let's say the spoke is bent, what I should do. You're able to understand, right? So first, I know like math is important. Yes, I understand. And I'm 100% advocate of math, and you really don't know how much time I struggle to understand the math in deep learning as well. But my effort is this, okay? I'm given 5 hours and I need to drive CNN, the entire concept, into somebody's head. If I start the math, I will stop in linear algebra only of dot product. But the intention is this. The intention is not to learn everything in the class. That's not my intention. My intention is if you're able to know this is how the flow is happening, and I'm interested and actually go to that extent of each of the thing and go inside, you will be an expert in that. You got what I'm saying?
yeah,
And
clear.
you have audience of multiple different varieties. Let's say people coming from physics, they like that. Some people like this gate, that forget gate, input gate, because for them, the gates and the transistors
Electronics.
excite them. For math people, I think the concept of classification, the concept of what is say the divergence, the metrics, the thing of how do you separate in non-linear, how do you separate in linear, that excites people, right? And with the class of variety of people having the thing together, and our thing is also to cover the syllabus as well. So the extent to which, so it's hierarchical in nature, to put in one point. On top, I learn about CNN, go little down to understand what is the structure, go little below to understand the math operations, go little below to see how the error surface will look like, go little below to see can I change few things to make sure I'll do the task at hand. So it's hierarchical in nature, and the life itself is hierarchical in nature. That's why CNNs or the neural network itself flow, right? Because even how we process also is hierarchical in nature. Like if I look at the screen, I don't look at the entire screen. I look at some part which is changing or some part which is important to me. And if I look at other, then I start zooming in or giving the attention to that. And that's why the current neural network is all attention based mechanisms. So if you look at any of the latest literature like BERT, PERT is one thing that is coming in NLP or anything, it's all attention is all you need. One paper came in some 2016 or 17 and that revolutionized everything, and now it is all attention based networks. So I'm
Yeah,
trying to give
because
the
I keep hearing that, whenever I read something in Medium or somewhere else, I keep reading. So they say, oh, CNN is full of flaws. This here's something new to do this, or for time forecasting, this is not good. There's a structure now
yeah,
called
time
VDOT, which is
forecasting
good.
is no
So
very
we
simple.
don't first we need to understand what it is to know its limitations to see that okay, I can go beyond this. So
Yes.
that is why I felt like the understanding is from three angles, right? One is from programmatically how it goes, and then mathematically how it goes, algorithmically, like what is the strategy behind doing this as well, you
But
know?
if we
So
have all the time in the world, if you're going to get into math, we'll be more than happy. Just write one paper so that we will also read next time. What is it there here? Okay, choose a
Sir, mathematics, my personal take is that, the implementation may change, but the logic or the math,
exactly,
they
yeah.
are, they are getting propagated.
Principles are so if you can share any resource, I mean, I
Yeah,
do
I
understand
will
that
send
we
it.
cannot
I will
cover
send
everything in the class, but if you can share something, you know, it will be helpful because most of the articles around also do not focus. It's either very purely mathematical, they go all the way to Hilbert spaces and Gramian matrix and stuff, or suddenly they are super easy, like showing the diagram that you were showing. So there's
Yes.
nothing in the middle that is actually covering, you know, somewhat simply how this ties to that. So that's why I was asking if you have any resources that would be helpful.
Sure, sure, sure. Sure, so I'll maybe, okay, I will actually send you one um, link, but it may not surface or it may not suffice to the level at which you are looking at, but this is called dive into deep learning. Okay, one of the book which is more mathematical in nature. It's a web book. You can just go there and um, so it might give you a little bit of a mathematical perspective. That much I can tell you.
Okay,
Okay.
that
And
would be
there is one more famous book. So the guy, this Yosho Benjo and there are this Gan, one more guy. So these three guys wrote a fundamental book on deep learning itself, but that can go over the head. Like they are into like manifolds and see once the manifold comes into picture, right? The problem is we cannot visualize. It's nonlinear in
I
nature.
know, I know.
And once it's non-linear in nature, it's like that Mobius strip. I start here and again I can't come back. I'll go somewhere else, right? So if I ask,
Homeomorphism, topology, and all that. I'm not a math student, but I have interest, so I have
yeah.
read
So
all
if
that. So
somebody
quite
asks me what is topology, I'll just tell that okay, it's just a system of continuous function. How take a thing, how that particular object gets transformed using a continuous function. So for me, that is topology, to applied kind of a thing. But if somebody comes and says that, do you know little more? I will say, okay, come, let's go to Hilbert space. Let's go to that metric and see what thing will support in that, what operations won't support in that. So it's all that hierarchical that I'm talking about. Very simple. And the you have more time, the deeper you go. But most of the time, what we do in the search also, do a BFS. Some arm that is interested, do a DFS.
yeah.
Depth first, right? So such kind of a thing because we can't cover the entire thing, right? So given constraints of time and kind of thing, we
Yeah,
need to.
agreed, agreed.
Okay, sorry for being philosophical in nature, but I'll be the most happiest if somebody can go into the realms of math, okay? Because I'm proper advocate of math itself. Yeah, and coming to this, any other questions in anything? I won't say under the sun, but under the realm of whatever thing that we are talking about, because I'm actually, if you look at the age and the kind of
My
experience
doubt
we
is, sir,
have, just 1 minute. So the kind of experience and the age and all that, and also the things that you have seen in life, I cannot comment on that. But something in DL and ML, yes, I can try to attempt that. Yeah, Varprasad.
by doing all these maths, Tesla car is going at 150. Sir, server is inside or maybe at outside. It is contacting the data center and running. That is my doubt.
Yeah, so the doubt is actually very simple. Okay, so they did two things. One is the Tesla car itself is heavy in terms of a very good processing, so that it will be able to take the data of the sensors that are there around the car that are put and streamingly inside, right? And will be able to do that basic kind of a processing. But that is your normal kind of serving that is happening. But if they want the retro or the kind of, if somebody asks me how is my 15 minutes of journey is there, if that is a functionality, it will go to the server, do the thing and come back. So the basic kind of inference that is happening in terms of, let's say for example, I'm not sure like what model they use, but definitely some at least the object detection model that I see is a single stage detection only they would have used, because multi-stage would have taken time. Single stage detector, you have 3 or 4 options: YOLO, SSD, RetinaNet, and maybe something else. And in my 90% of the probability, they would have used a mobile net or a RetinaNet per se, because the zipping speeds are around 150 FPS, 200 FPS kind of speeds that RetinaNet gives you. Now, if I want to infer that, I need a GPU to do that. So, in one question that I wanted to ask Varaprasad is, the infra is distributed both at server and client. The client has a minimum infra to do the inference of the things of object detection, then segmentation, and multiple other things also, because it looks at the sensors of the vehicle itself. It also tries to understand, let's say the guy is speaking, hey, car, take left. So it also needs to process that information of the owner, what is there in the inside the car, and trying to do that, right? So all that NLP, the computer vision, the text processing, and also pulling the data from the Google Maps, or I don't know which maps they're using. In US, so definitely Apple Maps is the best there. So maybe some version of Apple Maps kind of a thing. Oh, or maybe Google Maps, because they are more open source in nature. Apple are more proprietary, so I'm not sure. So some version of the open maps system, they need to get the GPS and that location and all that, and also some information about the traffics and all that, so that it will also take. So for example, what I heard is the Tesla itself has the internal network of all the Teslas that go on road. They also communicate, but not heavy, but like a, what do you say, some kind of knowledge also shares in terms of intra Tesla actually. So even that, plus the kind of noise that is there in the system, suddenly our man, so in India it's very difficult, that's a different thing, but in US the roads are well established, and you have that size, and not even 1 millimeter it reduces or increases and all that. So you have everything in, what do you say, it's like a scaffold that is given to you, and you ask me, can you build a structure? It's easier. But in Indian roads, you come and tell, suddenly you never know, some hijab row will be happening somewhere, and all the roads get blocked without even people remembering, right? Or something else will happen, maybe some ABC will happen. Hey, sorry guys, if I had hurt any of the feelings or any of the thing, nothing in mind, just I'm talking what's coming to my mind. Okay, I'm just open-mindedly telling.
Yes, sir.
Okay, suddenly some event happens, and suddenly you also see the guys who are coming on the right side instead of coming onto the left, right? So Tesla, if it works on India, it's I would say it's like all-knowing God kind of thing. That's why if you look at this, Intel started attempting this particular challenge on Indian roads. So if you go and look into some of the this particular history, right, or maybe in the Google, Intel challenge for Indian roads kind of a scenario is there, where they will give you Indian data set, and instead of street light, everything else will be there near the street light, right? Like somebody will come and tell somebody died, one poster near the street light, or near where the speed limit is there, they will put something else, right? Everything under the sun is there, and the kind of challenges that are there on Indian roads is completely different. In US, everything is set up. The guy, okay, 99.9% that the guy doesn't come onto the left if he wants to go onto the right, right? And they also follow the lane discipline and all that. But nothing against Indian kind of a thing. But what I'm saying is the complexity is that difficult. One more question answer is it's distributed both in the cloud, both in the client.
In other cars also.
No, everywhere it should be that. Everywhere it should be that. The bare minimum should happen in the client. The rest should happen in the server. But the only thing is, does the user allow you to share the data or not? It depends on the user. User can tell yes or no. But the contract is such that like 1.5 years they have to share the data. They don't have a choice. Because from that they build the better systems, right? So Varaprasad, when are you buying Tesla?
No, sir. Just we are studying only. Last year also it hit on roads at America also, but failure also happening there. Just we are studying just like how it is going on. That
Actually, I'll tell you the much more difficult pieces. The difficult pieces are not ML. Let me tell you this with the automatic car.
Yeah.
So
Yes.
there is this something called ethical AI. Okay, let's say I'm a Tesla guy. I bought, let's say, Varaprasad bought Tesla and he's going with his family inside, right?
Yes.
Or maybe I will take my example. I'm taking my family going in Tesla. Now suddenly there is a small girl that came onto the road. Now tell me, what is the decision that Tesla should take? If I apply a sudden brake and let's say a small baby is there inside the car, it's dangerous for the people who are sitting inside the car because they are not even aware of the situation. They just gave everything to driver and they're enjoying their own life, right?
Yes.
Now, if I don't brake and go hit the girl and go, now who is to be blamed? Is the Tesla algorithm should be blamed, or is the girl who came without notice should be blamed, or even there is no proper checkpoints where people can come onto the road, so government needs to be blamed, or that guy needs to get into some manual mode and try to go that, so the driver need to be blamed? Nobody knows. So there are a lot of ethical issues with respect to these decisions. Okay. So for example,
Yes,
somebody
sir.
wants to stop an accident. So by braking, he might stop a major accident. But the major accident could be averted, but the guys behind will come and bang into his car. No, who needs to be blamed? Who will pay for the insurance? No ethical answers are there. That's why if you look at this, right, MIT, last year or last year, 2019, US government gave $1 billion to MIT, telling that you set up a new structure, give us what are those ethical guidelines, because guidelines will come from academia and it will get integrated with what comes from the industry constraints, right? At least they need to do the framework, do the analysis, and because corporates don't have time, they require all new use cases, new money, new places where they can get all the business and all that. So if you look at that, they started a new center called Ethics AI Center, where their job is to create the framework. Not only for Tesla or automatic car, for the robot itself, like the any kind of AI autonomous kind of thing. Okay. So if you look at, so now just outside MIT, there are these robots which serve food. Robots which serve food and they also make food. So instead of giving the food, let's say it goes and slaps the guy who ordered. Now who needs to be blamed? You can't go and find the guy who wrote the algorithm saying that this particular use case you didn't handle, or the restaurant guy, or the guy who knows that robot. You don't know whether that guy is in 100% sense, maintain a distance. You never know. So this ethical is one aspect of it. The second comes is privacy.
Sir, may I add something?
Yes,
Uh,
Soumya.
yeah, sir, my take is that I may be wrong. So ethical aspect is really important and it
Yes.
must be respected. However, the main reason why it is not being successful is the economic viability. Once the economics are better, nobody is going to care about the ethical aspects.
But we are humans, so India cares about it, right?
Uh, we do care. I mean, the other lobby will be so strong. Just take example of the ammunition or the arms lobby in US or the tobacco lobby. So we all know that.
Yeah, the same guy gave to Afghanistan, and after 10 years, the same guy goes and kills everybody and comes back. The same guy funds Osama, the same guy goes and kills Osama. And now the same guy is giving ammunition to Ukraine, the same guy will fight with you, Russia.
One question here, a curiosity out of curiosity. When it comes to something like driving car, right? It is a much more complicated system. The people on the road, it requires a lot of reinforcement and training to get it ready. However, if you look at our trains, right, the tracks, the stoppage, the thing is more or less more predictable, far
Organized.
more
Yeah,
predictable, and maybe even separate truck lanes, highway lanes, and where there's no way that any vehicle can come inside, or even, I mean, for example, there are automated metro
but
trains that
trains,
are
yeah.
running in other countries now, like where
Correct.
there's no driver, nothing, there's not just a dabba there and in the engine cabin, and then
Right.
there's just
No, all these goods trains that have drivers, I think most of the things in US, because for them it is like start and stop there at the end. That's
exactly. So, I mean,
We
Any
also
reason why our government is not looking at that as an option rather than?
Oh, if you looked at that, right, very simple. It's the infrastructure, simple. Okay. I'll just give you one example. So if you look at the US system, we are here, we are not comparing everybody. I don't know whoever is taking wrong, but you just look at that, right? They have a separate track for the goods. They have a separate track for the passenger. They have a separate track for the local kind of things that happen, like local trains and all that. But if you come to India, let's say a metro and all that is separate, but local trains, the normal trains, and the kinds of government, suddenly they will come and announce some new train, right, for few days, and the goods train, it will never be on time, correct? Suppose if somebody, or if you just unify everything, it's all synchronization. If your system can make sure that you respect time, right, everything else will fall in place. We can have all these particular things where you can have these trains which can run without any driver and all that. But the problem is we don't have that. We compromise on the time, and the time is the most precious thing, right? Because the distance is fixed, distance is not going to change. It's the time that is actually the variable that's running. So once the t is fixed, right, V is anyway fixed. I can run the train at 200 also, 100 also, 50 also. It's just a machine. I can run it as long as resources are there. Only problem is the time t. And for that time t, I don't have a dedicated track on which this guy can go. Suddenly they will come and tell Rajdhani is important. Stop all the things, push it aside, and they will take it. Sometimes I saw goods train going back, going to a track where there is no ahead, come back again, take the track and go. Right. So the T is the most important. And if the discipline of T comes into picture, then most of the other things are done. Like why people take metro? Because they promise that in 10 minutes I will reach there, and in 10 minutes you reach there. That's why people take metro. Yeah, you're avoiding traffic, you're doing other thing. It could be economical, you're reducing the time. 100 things are there. But people can trust metro because of the time T. Did I answer your question? It's very complicated question, but it's the T.
I
That is
get it. I get it.
So for example, when I was in GE, I was having a project with GE Transportation. And the transportation is basically the rails that are going from Mysore to this Mumbai kind of a stuff, like that Hubli kind of stuff. And there we started a new thing of finding out the behavior of the driver. Like you have a camera in the front.
Whether
So the
it's
driver,
sleeping.
let's say he's sitting and he's yawning. I know that that guy is in danger, so it raises an alarm saying that boss, concentrate on the track. So many people are dependent on you. Or that guy is not looking here, so it will just generate the score, attention. How much of the what is it, the focus the driver has it on the thing. Or that guy can goes and does whatever, or he's sleeping, sleep detection, and he will just bang on, give the alarm. So we try to develop that system, and it is there now running in between Mysore and Hubli. The trains that go, right. You have, I don't know if you go to the driver's cabin, there will be one small like a tab kind of a thing and a camera, and the tab will generate the statistics and send it to his supervisor, and that guy gets rewarded or punished based on that whatever thing, right? Yeah, we are making the driver's life difficult, but we also need to understand the amount of responsibility he needs to take, right? Yeah. So just giving a scenario, like we are also trying to be more smarter in that particular nature. Like people are also looking at alternate mechanisms of this bullet kind of thing, like levitation trains or something. I don't know. They're trying to move between Ahmedabad and Mumbai. I'm not sure. They're coming with blueprint and all that, but it's all the lobbying. Like what Soumya was telling, the guy who has more money, he gets his idea across faster. Yeah, anything else? I know we are going a little philosophical, political, and all other angles, but this is important. The second thing I was talking about from ethical AI is perspective is side you keep. The other is the privacy and security. Okay. Why privacy? You'd have heard about this Facebook, right? It lost $200 billion in a day. Why? Apple just updated the privacy policy saying that you cannot grab the statistics of the user unless that guy explicitly gives you, right? Now in July, the same thing is going to happen with Android applications, because Android is now coming up in July. That same rule will come because everybody is worried about Google knowing where I am talking, what I'm talking, where I am there, what I'm doing. Like for example, Microsoft Teams is there now currently going around. And if I'm using a free version of it, God knows what data they're going to share. Like I'm sharing a lot of these this about whatever slides are there, much of open source and all that. Think of like people who are sharing some sensitive data. You never know what happens in Microsoft Teams, right? It's a video channel to discuss things. And if those guys have all the data, they are the most powerful guy. Simple. So Facebook is now looking at in July what they do. They're going to lose out. They're going to get hit. And Europe itself is planning to ban the entire Facebook because they're taking all the user stats and using it for advertising. Right? Now they are very clever that they know that's going to happen. Now they pivoted themselves and now looking into metaverse and those kind of stuff. But yeah, so we need to see. So the privacy and security is the second thing that is most important apart from the ethical AI. And privacy is of utmost importance because there are laws which can, data protection and privacy laws that are there which can affect the thing in terms of performance and
It's
business.
a very valid point because I was thinking we are not, let's say we get placed in some place where we have to be in charge of all this. We need to be aware because those companies, they have their obligation to legal
Yes,
and other regulatory authorities and
correct.
audits to ensure that there is privacy and protection while we are using these algorithms, while we are there
Exactly,
looking
exactly.
it up.
So, for example, so there is one more aspect of it to security. Okay, security is I'm not trying to look for ML for security. I'm not trying to look for ML techniques for security. No, I'm trying to look for security for ML also. Like for
Yes.
example, I'm trying, if I know the algorithm that those guys used, or if I know what inference that car can give you, I can attack using any of the security things, like I can snoop or do whatever, and I can attack so that the model will give you a wrong inference, and that can lead to accidents. You got what I'm saying? The
Yes. Yes.
security of the ML and the ML for security, both are important, and it's all the open space that's happening currently.
Yeah. So
And
on the security aspect, right? Is it like the ones that are provided by, for example, Azure? Let's say you go for Azure or GCP. They are
ah,
the ones who are giving the SLA and commitment for the security as
no,
well.
no, no. In that, there are, so if you go and actually start that, so there will be some checkboxes where you can give them that explicit protection for my data and ML. If you checkbox, your rate will go double.
Oh, okay.
So if it is like $100, they will charge you $200. So it comes with premium, but the basic security they give you, like for example, user authentications and the necessary permissions, so that only those people will come and all
Yeah,
that.
yeah.
But any of the attacks and those kind of things, you need to have the secure kind of thing. Like for example, Intel wants to make sure that security goes to the extent of running on the processor also. That's why they started a thing called secure execution of the thing, right? So if you look at this, there is called trusted environment.
Yeah.
So that means in the Intel also, in the processor where they are trying to execute, I have the security there itself. That's why they are called trusted environments, and Intel is actually driving that particular aspect of it at the processor level and not even at the disk or other kind of level. It's called trusted executed environments. Very, very famous, but I'm not sure. Intel is losing out on money, but they have to do it a little fast. Yeah. So these aspects I know because day in and day out we are trying to figure out what to do, what to do kind of thing. Because my role at SAP is about next 5 years, what is that will come into the market? What does SAP should focus on the market? Or next 3 years, what is the trend we need to pivot? So I'm in that organization. So because of that, I need to do a lot of thing about the new things that are coming up, like metaverse and whatever the hype that's happening around. Nobody knows what is there inside, but people are getting started doing wedding and all inside. So I really don't know what's happening, but we need to pivot and see whether it will go to metaverse or whether the next big thing is maybe all these all your blockchain, or we don't know, NFT or quantum, we don't know. So the exploration phases are there, but the learning that we have with respect to that, the difficult part is you need to unlearn, and only then you can learn the new things, right? So that is the I would say the challenging part. Yeah.
And so how do you keep yourself abreast with the new technologies or what new is coming?
So actually, so one thing I need to be very genuine with this. So I don't know everything that is happening in AI or ML, but I know in my work what is the state of the art that's happening. Like for example, if I'm doing object detection, I know what is the state of the art. Yesterday, what happened in object detection to that extent. But the other topics, let's say quantum ML or something ML or whatever it is, I know a base of it. Like maybe I have read one or two articles, or maybe the Gartenville project. These are the 10 different technologies. Only to that extent I know. But the work on which I am working on, like for example, the work in which those components are involved, neck to neck, you need to know what's happening there, or else you will be out of market. Especially in the research organization, right? It's like you do it on correct time or you lose out on everything. It's like that. Yeah, but lot to, because we have only 24 hours, it's difficult, and it's also projected towards what's there. So yeah, and I now want to come to the very important part of the course. I need your feedback. So one of the feedback that I got was from Shivpriya saying that little bit of math, if you put inside, could be useful. I'll take it, but provided it's not for this particular thing, not like AI03 again I'll come and teach deep learning and all. No, no, no. I want to understand in the genuine kind of a thing. What's the kind of flavor that you guys are looking, and is it really useful, or whatever kind of feedback that you want to give, I'm actually ready. Yes. And I won't take it personally, or sir, actually I wanted everybody to switch on the cameras because I'm very genuine when I'm speaking this, right? I want to take it to improve myself.
Sir, overall, the course is fantastic. Deep learning is really deep and to understand, and you really helped all of us a lot, encouraged us, and ensure that we all are participating. That is fantastic. And content is also really helpful. It is vast, but it cannot be. I don't think it cannot be drilled down further. One area is where, and again, this is about how people learn. So for me, something which I can repeat couple of times, so until unless it is imprint in my mind, that helps me a lot. Otherwise, I will jump from one subject to other subject without having time to revise, say, deep learning concepts. And revising all the content may not be possible for a person like me who has limited capabilities. I've seen some people who will remember everything by in one go or two go. In one of the institute, I've seen. So, but anything, some nuggets, or how should I create the notes myself, or there are some notes which are readily available, or combination of both? That is a guidance, or you can say feedback as well. So I'm also seeking this from you.
Instead of slides, you also want some notes to be there.
Or should I create those myself? No, I'm not saying slides are helpful. I'm saying slides must be there because notes will be points.
You're saying additional to that, there should be some summary notes or something.
Yeah, something which I can revise. And then if I forget something, I go to slides. Okay, these are the slides for the
okay. I think it's an interesting idea. So actually, maybe I try to do it in a bit. Okay, for example, if you look at the first, second, third, whatever classes that I have taken, after the first class, last 15 minutes, I spend revising all the topics that we did. Right. Yes. Even in the last week ending, we spend around half an hour to see what all things we covered in the last 3 classes. Right.
Yes.
So, but summary could be really useful. So I think I'll ask the students only to do it. Like for example, let's say I'm trying to cover this, okay, this particular topic. If students can get their own summary, and maybe Hasita or somebody who is doing the coordination, if they can put the things together, you have a summary notes. Like, not that for everything you need a summary. Let's say that thing has around 200 slides. Like, for example, some of the slides per week are around 300, 400. 10 people in the
I
class.
think I'm not able to hear you, sir.
Can you guys hear me?
Yes.
Okay.
Yeah.
So let's say 400 slides are there in that class, what I projected. Okay. Not that everything I'm covering. So 10 people are there, 40 slides per person, or 20 people are there, 20 slides per person, right? You summarize the 20 slides and put it there, and now you do an aggregation or concatenation. You basically get the summary of that particular thing. Hey, Hasita, you need to take this feedback, where I'm not sure, maybe it was useful to this class or other classes also, that just create a small summary, like each participant based on the rule number or something, break down into different slides, create a simple summary for that set of slides that they are assigned, and give back, so that that aggregated thing could be put as like a notes or summary kind of thing. Hasita, can you hear me?
Yeah, sir, we can do that.
Okay, just keep that in mind and note it somewhere. Yeah. Yeah.
Yeah, sir.
Yeah, so that is fine. So I'm trying to look at the, yeah, thanks Soumya for the feedback. Anything else, guys? Kathiresan is like, oh, 4:30, man, just leave me, no?
Not like that, sir.
Srihari here, sir.
I had a similar,
So,
I mean, point of Soumya. Like, there are way too many concepts that has been covered, and I mean, during the class, it looks. I mean, I am able to understand. I am able to catch or follow what you are telling, and again,
After
like
the
coming
time you open, it's
after a
became that.
week,
Completely, I understand.
yes, I felt like a little lost. So it is not with respect to what is being taught, whatever is there in the slide, or if I go through the video, I'm getting it. But then if there is something that complement it, it will become easier to put it in our memory rather than keeping it as a flash memory.
Yes, great. Yeah.
Srihari
Hasita
here, sir.
noted down. Yeah, yeah, Srihari, tell me. I hope your
One
family is
thing.
safe. Srihari, hope your family is safe. Everything is.
No, not really. It will take at least 3-4 days more.
Take care, man. Take care. I can see in your face itself a lot of what to say, concern actually. Yeah. Take care. Take care. Family is
Thank,
first.
thank you. Yeah. So as all of us are experiencing that, the depth of the subject is quite high. So maybe considering the amount of syllabus to be covered, instead of finishing in 4 weeks, can it be stretched over, say, 2 modules, DL1 and DL2, because it will.
Hey, one just if you don't mind, just one thing. Huh? Hasita, is Shino there around?
Yeah, sir, do you want me to pull her
Yeah,
in?
just ask her to come, no?
Okay, sir, yeah.
Because these are the decisions of. So this is ML ops you're talking about. I'm talking about ML engineer. So different. So operations and the logistics and all that. You need to ask the people who matter in terms of decisions, right? Just a minute. Hey, can you ask her to join?
Yes, I'm calling her.
I'm all over the bad books of Shinu actually. Because last class, I think 6 people copied and I gave zeros to them.
Sir, we'll need your. That reminds me about some guidance about, for the final exams as well.
Yeah, that is nothing, man. You understood your class, you can just go and rock it there. So it won't be like explain CNN, explain CNN in 20 words. No, it's going to be MCQ and maybe one problem, like what you see, not as complicated as assignment, but a smaller problem where you could do it in that set of time that is given to you. And the MCQs will test your like understanding of the subject itself. Like given an open book also, it's like okay, like you were very able to do it kind of thing. But don't do open book and all. These guys are putting on videos and be careful. But what I'm trying to say is, suppose you understood that concept, it's very easy for you to do that, right? And if you did your assignments well, then the problem that you're solving also is easy to do that. So, and no, this explain CNN how it is different between RNN and CNN. Those questions won't come. That much I can tell. Yeah. These are practical questions of whether you understood or not, period. Does it help you? Yeah.
Yes, sir, we got.
Is Shinu there or? Okay. Sorry, Srihari, continue. I am not sure whether we could get her into this, but I understood. So you're saying DL, you break down into DL1 and DL2 and go a little
Yeah.
more deeper, or do the
Or-
same content but more into each of the thing. But
Yeah.
where did you feel the lag? Is it with respect to the code that we are looking at or with the material that we are looking at?
No,
I know we're going it faster.
the concepts are little hard to digest, so we would need little more time.
So what you're saying, per slide, spend more time for you to actually understand the concept itself.
Correct.
And make it DL1 and DL2.
Yeah.
It's an interesting question. You have constraints with respect to the program module, and I'm not sure, like a lot of logistics are involved. Yeah, Asita, tell me.
Yeah, so Sheenu ma'am's in another class, but we have Pulikeshi sir with us. He can handle the questions.
Hey, hi Pulkeshi, how are you?
Hi, sir. I'm doing good, sir. How are you, sir?
Yeah. So yeah, I'm fine. So there are two concerns that came up.
Yes, sir.
The concern number one,
Yeah.
I think Funny also is joining this too. Hey, hi Funny. So hi Funny and Pulkeshi. So there are two concerns that came up in this class.
Okay.
Number one is, can you actually have a summary of the class itself, right? So, and the second thing is with respect to the DL is so deep that can you break it into DL1 and DL2 so that we can have double the time to basically digest and do your concepts. So these are the two feedback that came. I think you might note now. And
Yep.
if you have any initial comments to make, you can do that. So for example, for summary, what I told was, let's say I am covering 100 slides in the class and there are 10 people in the class. For you allocate and for 10 slides, you make the summary and put all the 10 people together and you get the summary of the class itself, right?
Okay.
So that was one thing that I told, but regarding the DL1, DL2, I'm not sure. I'm not uh, empowered to take any decision or give any kind of comment there. Yeah.
Sai, this is Mithun here. I'm with Pulkeshi. I'm one of the mentors here.
Yeah. Please.
I was just listening to the conversation. So we have noted both of these points.
Okay.
One is about the summary part of it. We have noted this.